Hey guys, so last lesson you did power rule, scalar multiplication, constant, all that stuff. So today we're going to focus on exponential and the trig functions. So really, after you practice a bunch of these today, you need to get on your note cards and start writing these down so you can memorize them, okay? The most common errors we can make with trig functions, though, are the sign. Remember how when we take the derivative, I said there's that pattern of all the c's going to negatives, right? Well, the idea is if you look at our, like a little bracket here, or a little cross section, right? Derivatives, I would go clockwise. And as you can see, sine goes to cosine, and that's positive, where cosine goes down below, and that's negative. But if we go the other way, our cosine, our positive cosine goes to a positive sine, our positive sine goes to a negative cosine. You can memorize it this way. You can memorize them just from there. The other thing I tend to do when it comes to integrals is after I take the integral, I look at it and I say, okay, if I were to go forward and take the derivative, are my signs correct? Because you can always check by going forwards just to make sure your backwards was fine, okay? And I do that a lot with trig because of the sign errors. So let's look at what's going on with some of these examples, okay? We have the integral of -3 sine x dx. So I'm going to show you what I didn't show you last time with that scalar multiplication, right? The scalar multiplication says I can take the coefficient and put it out front. So now I'm just looking at the integral of sine x dx, which I can come right back up here to my rule and say it's negative. So the -3 stays out, and if I take the integral, I would get negative cosine x, and then don't forget to have that plus c. Now, if I were to distribute that -3 out, this becomes 3 cosine. Now, I know it's so tempting to say -3c, but c, we don't know what number it is. So c times -3 is still a c. We just don't know what it is. So it is okay then just leave it as c. You do not want to say -3c. All right. Here again, we're going to take them like our summation rule, right? So I can take the integral of e to the x minus the integral of 2 to the x. Again, these are just rules up here, so let's follow them. The integral of e to the x is e to the x. And then we go minus. Now let's look at our rule. A to the x, 2 to the x. So we keep it on top. So 2 to the x is in the numerator, and down below is ln of the base. And ln in this case, the base is 2. And then don't forget to put that plus c. All right, just like we did in last section, sometimes it's easier to make sure that you rearrange it so it's easier to do your integral. So let's change the formatting right now. This is the integral of 5. This would be t to the 2/3 plus 3 cosine t minus 1. I'm going to put that in the parentheses because it's dt. I'm going to do each of these separately. So power rule, trig rule, constant rule. So 5t, add 1. So if I add 1 to 2/3, I get 5/3. Divide by that exponent plus 3. The derivative, the integral of cosine, if you look above, is sine minus, this is our constant rule, so I have this 1 and I attach the variable. At the very end, I have a plus c. Now I am going to simplify this a little bit more. Remember, dividing by 5/3 means multiplying by the reciprocal, which is 3/5. Okay, and what do you know? These 5s cancel, so I get 3 t to the 5/3 plus 3 sine t minus t plus c. Done. All right. Now remember I said that scalar multiplication is really going to help us later. This is where it helps. If you see this 4 in the denominator means what? It means 1/4. So I can look this as 1/4 integral of the secant y tangent. Now for now, because we haven't gotten into anything crazy, I must know that this has to be a rule. So if I go up here and I look for secant tangent, I see it's right here. Secant tangent, the integral is secant. So we get 1/4 secant, we're in y, and then don't forget that plus c at the end. So we need to be able to recognize these in the rules. All right, let's do one more where we're actually going all the way and we're finding that c value. So first we're going to take the integral. So we get f of x equals, and if we look up at our rules, secant squared, the integral of secant squared is negative cotangent x, and then we have a plus c. Now what we're going to do is say that 3 equals negative cotangent of 5 pi over 4 plus c, and we're going to solve. So we must remember our unit circle. 5 pi over 4 is over here, which means we have the coordinate negative square root of 2 over 2, comma, negative square root of 2 over 2. By the way, I've asked you multiple times to be writing your unit circle out every time so this becomes habit. But one of the other things I want you to remind you of is 5 over 4 is a little bit over 1. So I know 1 would be my 180. So I'm down in the third quadrant. And I know it's over 4, which means square root of 2 over 2. And since it's in the third quadrant, that means they're both negative. Now, cotangent is cosine over sine. So cosine over sine would be the value of 1. So this part here is the value of 1. So I get negative 1 plus c. So c equals 4. So my final answer for this is f of x equals negative cotangent x plus 4. All right, this was a short lesson because this is really practicing those trig functions and getting those memorized.